Today we are going to start with a new topic, super important topic that is called quadratic equations. Why it's an important topic? Because you will use it in many other subjects, in physics, in chemistry, in other types of math. So it's going to be a super important topic. Quadratic equations, of course, it means it has a power of 2. So that's why they can call it also second order or second degree equations. They have this specific structure, ax squared plus bx plus c equals 0. This one that we have here, ax squared, it's called normally the quadratic term because it's the one that has the power of 2. This one, the bx term, it's called the linear term because of course the power of x is 1. And this one that do not have x, normally it's called the independent term. Of course, this one is the general structure of a quadratic equation, but maybe we can miss the middle or the last term. Of course, we cannot miss the first one because if we are missing the first one, it will be a linear equation, not a quadratic equation. So let's see the types of quadratic equation that we can have. The one that has A, B, and C, it's called the complete quadratic equation. So if we have the three terms, we have something that multiplies the x squared, something that multiplies the x, and an independent term. It will be a complete quadratic equation. What it will be if we are missing the middle, the bx, or we are missing the c term. If we have only two terms, that means the ax squared and another one, we will call it the incomplete quadratic equations. Those will have two terms. And we will have two of them that will be a little bit different. We have the one that is called the mixed quadratic equations. In that one, we have only ax squared and bx. We don't have the c term. We don't have an independent term. And we have also the ones that are called pure or incomplete pure quadratic equations are the ones that we only have the x squared term and the independent term. So those three types, the complete and the two incomplete quadratic equations, are the different structure that we can have in the quadratic equations. So let's go to talk a little bit about the graph. When we are talking about the quadratic equation, the graph will be something that we will be calling a parabola. A parabola is going to be the form that a quadratic equation has. It's normally a curve that we have here, and it can be in different points of the graph, but the important idea is that we have a structure called the parabola. Of course, we have the x-axis, the y-axis, and it says here we have a little point here that is where it crosses the y-axis. It says the value c, remember the value c, it's the independent term. The value c indicates where it crosses the y-axis. So this little number, if we have an independent term, that independent term will tell us specifically where in the y-axis the parabola will cross. We have three different methods for solving quadratic equations. We will see all of them in different videos. We will talk about how to solve a quadratic equation by factoring. We will talk about how to solve quadratic equations by the general formula of quadratic equations. And also, we will talk about a little bit how to solve a quadratic equation completing the perfect square trinomial. The solutions, when we solve a quadratic equations and we know the values of the solutions will tell us where it crosses the x-axis. So in this case, it will tell us where specifically the parabola crosses the x-axis. So we have two different stuff. The value c indicates where it crosses the y-axis. The solutions of the equation will tell us where it crosses the x-axis. So let's talk about a little bit about something that is called the discriminant of the quadratic equation. The discriminant has this little formula. Remember, a, b, and c are part of the quadratic equations. They are numbers. They are coefficients of the equation. It says, if we use this little formula, d equals b squared minus 4ac. If we do this one, we can now so much information about the equation. So we have three possibilities. We can set like d is greater than 0, d is smaller than 0, or d equals 0. We have these three possibilities. So what can we know only with this little formula? If d is greater than 0, d is smaller than 0, or d equals to 0. If d has a positive value, that means it's greater than 0, it means it will have two different real solutions. So if d is bigger than 0, we can note that our little equation will have two solutions with real numbers. That will mean, because we have two solutions, that our parabola will cross the x-axis on two different points, because we have two different real solutions. When the discriminant, the d, it's smaller than 0, that means it's a negative number. If we have a negative number in the value of d, that means maybe we can talk that our equation has no solutions, or we can talk about our equation has imaginary solution. Why has no solutions? Because we will see that the parabola do not cross the x-axis. So that's why only with knowing the value of the discriminant we can know that the parabola cannot cross the x-axis, and that's why x has no solution. And what happens with d? The discriminant equals to 0. If d has a value of exactly 0, that means instead of having two different solutions, we will have only one solution, and it will be a real solution. And what will happen with the graphic? Of course, it will happen that the graphic will cross only in a specific point of the x-axis. Remember, if we have two different solutions, it will cross on 2 points. If we have no solutions, of course, it cannot cross the x-axis. If we have one real solution, it will cross only on a specific point of the x-axis. So let's see some exercises of how to use the discriminant to know the information of a quadratic equation. So let's see. Of course, we are talking about only knowing the information of the equation by the discriminant. Remember, the discriminant formula is going to be d equals b squared minus 4ac. So in this case, the first thing we need to know is, remember, a quadratic equation must have the structure ax squared plus bx plus c equals to 0. So what happens in this specific example? If we pass all to the right, it's going to be 2x squared plus 8x minus 3x plus 1 equals 0. So it's going to be 2x squared plus 5x plus 1 equals 0. That means a has a value of 2, b has a value of 5, and c has a value of 1. So we can apply the discriminant formula. The discriminant is going to be b squared. So it's going to be 5 squared minus 4a that multiplies c. In this one, it's going to be 25 minus 8. That means the discriminant, it's going to be 17. That means the discriminant, it's greater than 0. So what can we know about when the discriminant is greater than 0? So first of all, about this equation, it has three terms. It has the a, the v, and the c. So we can know that this specific formula, the quadratic equation, it's a complete quadratic equation because it has a, b, and c. So that's the first thing we can know about this equation. What else we can know when the discriminant is bigger than 0? If the discriminant is greater or bigger than 0, in this one, it will mean that we have two different real solutions. Remember, if it means we have two real solutions, it will mean it crosses the x-axis 2 times. And because the letter C has a value of 1, it will tell us specifically where it crosses the y-axis. So I'm guessing a little graph. It's not the real graph, but we will know that it will cross also the x-axis on two specific points. I'm guessing those points because we are not solving the specific quadratic equation, but we can know that it will cross specifically on 2 points of the x-axis and specifically on one in the y-axis. So that's why we can know many information or much information about the equation when we have the value of the discriminant. So let's see another example. So let's see, the second example, we have an equation like this. So the first thing we need to know, or the first thing we need to do, is we need to have this specific structure, the structure of a quadratic equation. So we need to multiply everything on the parentheses and so to become the structure of a quadratic equation. So here it's going to be this one that multiply the two of them. So it's going to be 8x minus 8. This one that multiplies the two of them. So it's going to be minus 3x squared plus 3x. And the other part of the equation, we have a binomial squared. So it's going to be the first one squared minus 2 times the first one multiplied by the second one, that it will be 30x, plus the second one squared, that it's going to be 9. So we need to pass all the terms to the same side of the equation. And in this case, if we pass them to the right, it's going to be 28x squared because we have the 25. The minus 3 will go to the other side as a positive 3. What happens with the x? We have 8x plus 3x, it's 11x. If we pass it to the other side, it's going to be minus 11 minus 30. It's going to be minus 41x. And what happens with the numbers? We have minus 8 that will go to the other side as a plus 8. So it's going to be plus 17 equals to 0. So that means we can know that A has a value of 28, B has a value of minus 41, and C has a value of 17. So in this case, remember the formula for the discriminant, it's going to be B squared minus 4AC. So it's going to be minus 41, all of it squared, minus 4 that multiplies A, that multiplies C. So in this case, it's going to be, if I do minus 41, all of it squared, it's going to be 1681 minus, and it's going to be 1904. So that means the discriminant is going to be minus 223. That means the discriminant is smaller than 0. So what can we know if the discriminant is smaller than 0? First of all, the quadratic equation has A, B, and C. So the quadratic equation, it's a complete quadratic equation. And if the discriminant is smaller than 0, that means if it's negative, we know that we can say it has no solutions. Or we can say that they are imaginary solutions. It's the same. And also, of course, because it has no solutions for x, or they are imaginary solutions, do not cross the x-axis. And of course, maybe we can know, because the value of c is 17, that in the specific point of 17, it's where the specific parabola will cross. So maybe it will be something like this. I don't know. The important part is that it do not crosses the x-axis because it has no solutions for x, or the solutions for x are imaginary numbers. So let's see another example. So let's see. If we have this example, it's going to be very similar. First, we need to have the structure of a quadratic equation. So we need to multiply all the parentheses and send them to the same side of the equation and equalize it to 0, etc. So let's do it. In this case, it's going to be 10x minus 5x squared equals 10x minus 10. So if we send that to the same side, I will send them to the right in order to the x squared to be positive, or you can send it also to the left. It's going to be the same. So in this case, it's going to be, if we send them to the right, it's going to be 5x squared. What will happen with the 10x? It will be 10x minus 10x, so the 10x will disappear. And the minus 10, it will be here. So equals 0. So what happens here? We have that a has a specific value of 5. We don't have bx term, so b has a value of 0. And the c, the independent term, it's minus 10. So what can we know about this quadratic equation? This quadratic equation, it's an incomplete quadratic equation because we don't have the 3 terms, we only have 2 of them. And because we only have the x squared and the independent term, this one, it's a incomplete pure quadratic equation. So this one will be an incomplete pure quadratic equation. What about the discriminant? Let's check what will be the value of the discriminant. Remember, b squared minus 4ac. So in this case, it's going to be 0, all of it squared, minus 4, that multiplies 5, that multiplies minus 10. So in this case, it's going to be d equals minus multiplied by minus, it's plus. So 5 times 4, it's 20, times 10, it's going to be 200. So in this case, it's going to be a positive discriminant. This discriminant is greater than 0. So if the discriminant is greater than 0, we can say, okay, in this specific one, it has 2 solutions that are real solutions, 2 solutions with real numbers. And we can know also that the parabola will cross the x-axis 2 times. And we can know also, because the value of c is minus 10, that it will cross the y-axis in the value of minus 10. So maybe we can have something like this. I don't know. That it crosses the x-axis on 2 points. It crosses the y-axis specifically on minus 10. And of course, the specific quadratic equation will have 2 real numbers as a solution. So let's see one last example. So let's see, in this case, it's going to be the same. First, we need to have the structure of a quadratic equation. So in this case, it's going to be 8x squared minus 8x minus 3 equals minus x squared minus 2x minus 4. So if we send them to the same side and equalize it to 0, it's going to be 9x squared. What happens with the x minus 8? The minus 2 will go as a plus 2, so it's going to be minus 6x. The numbers minus 3, the minus 4 will go to the other side as a plus 4, so it's going to be plus 1 equals 0. That means we have a complete quadratic equation. Remember, a complete quadratic equation had the 3 terms. A has a value of 9, B has a value of minus 6, and c has a value of 1. So we can use the formula for the discriminant, and it's going to be b squared minus 4ac. So it's going to be minus 6 all of it squared minus 4 that multiplies 9 that multiplies 1. So the discriminant is going to be 36 minus 36. That means the discriminant equals exactly to 0. So what happens when the discriminant equals exactly to 0? That means it has only one solution. It has one real solution. And we can set also that it will touch the x-axis only on one point. And of course also, because the value of c is 1, we know that it will cross the y-axis specifically on the value 1. So maybe we will have something like this, that it will touch only maybe on a specific point of the graph. So that's the importance of the discriminant. Only doing the little formula b squared minus 4ac, we can know so much information about the specific quadratic equation we have, the types of a solution, where it will pass in the x-axis, where it will pass in the y-axis. So that's why the discriminant is so important for the quadratic equations. So in the next video, we will start solving the quadratic equations.